Hello, everyone. Thanks for joining us today to talk about the real value of Domo in data science. My name is John Stevens. I am a data scientist here at Domo on the consulting team. So I work with our customers to help them do data science in Domo. I'm joined today with Andrew Chafin, who is on the pre-sales side, also focusing pretty much entirely on data science. So we have a fair bit of background, both educationally and professionally, in data science and within Domo. I think I've been here about 5 years, and Andrew's been here about 6. So we've spent a lot of time in the product understanding what's going on, as well as working with data science. And so we're excited to share with you some of the things that we have found and learned that may be able to help you take Domo to the next level. So data science is a combination of process and technology. So we're going to go over a little bit about our process and the way things happen inside of our consulting organization, as well as the process for data science. And really, the difference between doing data science in kind of an isolated environment, where you're just kind of doing one-off models and reports off of that, versus putting a model into production, which generates its own challenges. And when you think about the technology stack that underlies both of these things, they're a little bit different. Some pieces are the same. And the value that Domo really provides is by having that all in one place, so that you can go from the beginning of the process to the end, being able to share your results and hopefully take and drive action based on the models that are produced. So this is a slide showing our process that we try and go through to help our customers get the most value out of their data science engagements. There are 6 stages here. The first one is preparation. And all data science projects start with this. You have to actually get the data first. And so we walk through, we have a number of assets that we've produced to help you prepare your data so that it can be ready. Then we assess the data quality, anything that needs to be done with it. Our analyze phase is where we start getting into the model building, which is the really fun part of data science, figuring out what models are the best fit, how do we tune them appropriately. Then we review this to make sure that everything makes sense, then implement it, which means put it in production so that it will run on a schedule over and over again, saving time, hopefully, for you as a data scientist so that you can move on to the next big problem and have fun. And then finally, we hand off. Okay, so now let's get into the non-production data science process. It's something I've done a lot of. I know most of the people that we've worked with have done a lot of this. If you're not putting a model into production, there's 4 general stages that you go through. So it is getting the data, cleaning the data, maybe doing some feature engineering, getting the data ready for modeling, finally building a model, and then presenting your results. And when you do this, there's a lot of potential friction and problems that can be generated. So just in the first thing, where we are looking at data acquisition, getting the data right. It's data science. You can't do data science without data. You need to go get some. So there can be a very complicated process for getting all of this data. You may have to pull it from websites. You may need to pull it from a system or various systems. This, within an organization, can cause some problems where the data scientist doesn't own the system, and so they need to work with other people, with system owners, with IT, to get the right data that they need that's going to be accurate enough for them to do their job. And so there's a lot of back and forth that goes on of a data scientist saying, well, I think I need this data, and the system owner then coming back or providing that data only to find out that it's not actually the right data that you need. And so without a really good working relationship with the system owners, there's a lot of time that is wasted in going back and forth for asking for this column or this column or this column that may or may not be right. If you are the system owner or you have more control over the data, this can be a much easier process where you know the data is right, you know what you need, you understand that, and you're able to just pull it and grab it. Once you've got all the data that you need, then we move on to the next piece, which is the cleaning and engineering phase. So in traditional BI or analytics, or reporting, when we're combining data together, a lot of times it's to get the right columns of data. So we need our sales data. We need maybe to combine it with marketing data. Let's make sure that we have the columns of data in our data set that represent the right things. And when we go into a data science realm, we pivot a little bit and we start looking at the individual rows. So are the rows complete? Is there missing data? And is that data missing at random or not? Because that changes what we can or can't do with it. We need to start looking at where the nulls are. What's the unit of analysis? What does a row actually even represent? Are we trying to figure out, what employees are going to churn, and we need one row per employee, or do we need a little bit more granularity, one employee per month, so that we can see the change in that employee over time? All of these factors impact how we build models. So once we get our data in the right rough shape, in terms of we've got the right columns that we need, we've got it aggregated or disaggregated to the row level that we need, then we move into the feature engineering part. So we need to dig deep into the data and understand at an individual column level what's going on in this column. Is it skewed? Is it normally distributed? Do a lot of work on the statistical properties of that data, because again, this impacts what sort of models that we can run and how well they will perform as we do our analysis. So those two phases combined usually take about 80 to 90% of a data scientist's time. It's incredibly time consuming because it provides the foundation on which then you can do the fun part, which is building the models. So that's our next phase, model building. So we take all of our data that has been carefully cleaned and vetted, and we analyze it. We run a whole bunch of different algorithms, and we test and tweak. Honestly, this is the stuff that the data scientists live for. This is the most fun part, building this together. And once we have that accurate model, then we're able to derive all sorts of insights from the patterns that the mathematics underlying those models have found. And so we have our model, we've built everything, and then it's time to communicate our results. So this could be in the form of a report. This could be in the form of some recommendations, a PowerPoint deck, whatever. But the whole point within a business context is we need something to help us drive action. From a leadership standpoint, the reason we want those models is what is it that we need to do next? And so some of our use cases that we've actually worked with have been people who have built models to figure out, employee churn or customer churn. And they want to know who's likely to churn so that we can develop an intervention. Or what factors are the biggest things, so maybe we do something around that. So action is the biggest piece, and so a data scientist has to communicate all of their intensive work and the insights and the values to the larger business community, and that's then kind of the end of a project. So this is non-production data science. When we move into the production data science, things change a little bit. We have all of the same steps that a non-production system goes through, but it is taken to a whole new level with a few new things added in. The main reason is because we need to have this all running in an automated fashion. We can't just do it ad hoc anymore. Everything has to flow. I remember hearing Elon Musk talk a little while ago about, designing a car is hard. But designing a system to build a car is exponentially more difficult, a gazillion times more difficult. And this is the same thing that happens with production data science. So if we look at those stages again, data acquisition, not only do we have to be able to pull it from multiple sources, but we need to be able to pull it consistently on a schedule to get everything in that we need. There's a lot of things that can go on with this. Not all systems get updated at the same time. So we may need to figure out what is the timing and the frequency of which all of these pulls need to happen. What does that mean if they don't all get pulled, if the data from different systems don't get pulled at the same time? It can be a scheduling nightmare. And it's something that needs to be figured out so that we have the most accurate data to then feed our model. The data cleaning portion and feature engineering, also something that has to be completely automated. I was talking with someone just the other day, and they were saying how every time they need to go rerun their model, they grab the data, and the data is, of course, not as clean as they would like, so they have to transform it. And so you have to change state names from, just an acronym or just a lowercase acronym to the entire state. Maybe it's spelled wrong. And every time you get one of these errors, if you put that into the model will break, which is not acceptable in a production environment. And so you need to have an automated way to get all of the data you need, process it based on all of the rules that you have, and more than that, flag it or error loudly so that you know when something new has happened and you need to go fix it. The model building pretty much stays the same. Like once you have the data, you build a model the same way you always have, by looking at things, experimenting, doing the evaluation, all of the fun stuff. That's pretty much the same. But then, once you have that fantastic model, you need to put that into a system where it can automatically, again, and this is the theme, the automation, automatically take all of the data that has to be perfectly clean and then run it through the model to score the new data that it's never seen before, and then produce those outcomes. And then finally, we have the communication and the action. The communication and the action also is an automation piece, where people need to be able to look at this at a regular basis, continually to figure out what they need to do and what the impact is of the interventions that they've designed. The nice thing is, within Domo, all of those things get a lot easier. So for our data acquisition piece, we have our connectors, where we can pull data from any sort of system, whether that's a local system or a cloud-based system. Anything you've got, we can automatically pull that in. Using our data flow technology, we can clean the data. So this can be done either in a Magic ETL process, where we've got a bunch of little widgets that you can drag and drop in, connect them all up, so you can clean all of the data that you need in a process. If you need something a little bit more robust, and you know SQL, we have SQL data flows. And so in there you have all of the power of SQL to do your transformations and modifying the data to get it in a state whereby you can do the modeling. This is something that we try and leverage a lot in our engagements, where we've actually got data validation scripts that not only go through and transform the data and clean it in the ways that we do know, but then we do another step of data validation where we're looking for the max and the mins and are all the categories there. And using SQL, we build out this flow that will alert us if there's anything that falls outside of the normal range of what we're expecting. And that way we make sure that our data is absolutely pristine for the model building. Again, like I mentioned before, model building, use whatever tool you want. So I'm a fan of our studio, like Jupyter Notebooks. I build my models there, and one of the things that Domo is getting shortly will be Jupyter Notebooks that are integrated more closely into Domo. So you won't even have to pull the data out into your own local machine or into whatever service you use, but you can actually just use Domo for that as well, for all that iterative exploratory analysis and model building. Once we have those models built in Python or R, we can then use the scripting tiles as part of the data science suite in Magic ETL and process the data. And once we have that, it will run on the schedule. It's just like any other data flow. New data comes in or on a schedule, it kicks off the job, it processes all of the data, outputs a whole bunch of new data sets, and then those data sets can be used in pages and cards and alerts for all of that communication process. So using the Domo technology stack, we actually can automate a lot of that work. So we're scaling up you as a data scientist, or at least that's our hope. That's why we have this technology, is that you can take all the skills that you have and try and automate away the boring stuff, focusing on the fun part, which we all really want to do. So now that I've talked about the whole process and kind of how Domo can fit into it, I want to show you. And I want to show you a couple of dashboards. The end user dashboards, we're going to actually start from the end. We're going to start with those end user dashboards that can be used for people to manage their business and work our way back through every single piece of this process.
Okay, so here is my dashboard. And I wanted to start with our communication dashboards. This is what we use to communicate with all of the business users who are consuming our model. So it is built for them. And the background on this, it's a use case where we are looking at the employee churn. So we want to know what employees are going to quit and when, so we can figure out what interventions we need to stage. And so on this dashboard, very first thing is who it is who's going to term. So we have their names, their predicted term date, and a couple other pieces of information about them. What their risk is, family they're in, and their last performance. And so, as you can see, as I'm hovering over some of this, my other cards are also filtering. And this is really handy because if I want to look at, say, just what's going on in finance, I can click there and have all of my other cards filter down so I can see who the most important people are. If you're familiar with our PDP feature, then this would work for them. And so everybody who saw this dashboard would only see the people that they're in charge of and they've been assigned to. So I can look at finance. If I wanted to look over here and just see the moderate risk population, then here's everybody. Clicking on it again will remove all those filters so I can see everyone. Now, I've color-coded these by their risk. So immediate intervention is dark red, high risk is low. And then you see I've got some of these that are grayed out. So they're actually high risk, but when you look at their performance rating, it's really low. So I don't really care as much if these people leave because they're not high performers. And so I'm kind of okay if they leave. I don't feel like I need to intervene on that. Of course, I could change that at any time by going in and modifying the card. So my first collection here is really all about finding the people who we need to intervene with. And as I scroll down, the next thing that I need to know is why. What are the things that keep people around? What are the things that push people away? And so this card shows the standardized coefficients from the model. You can see the biggest thing is management succession. People who are on a path for management stick around a lot longer. And so this is one of the things that I can look at to try and figure out what I need to do. Maybe this person needs to be in a management succession. If they already are, let me look down at the next things. So last bonus, last pay increase, or total base pay. These are maybe things that I can think about changing to keep the people around that are at high risk of leaving right now if I want to keep them. So it's all about tailoring the intervention. Now, there may be the case where I want to do something bigger, a far larger change than one-off interventions. And for that, this app is really helpful. So one of the people on our team named Vishaka built this. She's incredible. And we can pick a couple of things here. So our x-axis is going to be our 5-point rating scale. Scroll down a bit so you can see, how well did they score on their last review? 1 through 5, 5 being the best. And then here's the average number of months that these people stay with the company. Now, if I wanted to change things en masse, I could start to look at, well, let's see, what happens if I increase their last base pay from 3 to 7? And we see that everything moves up. Again, it's just applying the coefficients. It looks like there's a bit of a difference where the 3s and 4s sometimes behave a little bit differently. So I can get a little bit of a change just by modifying this. However, if I change the equity grants, I get a much bigger lift. And so by using this, I can kind of play around with and say, if we increase that here, we drop that down, where can I get it to a point where I'm satisfied, where I think in general, the entire population will be doing better. And I can play around with scenarios. And so that's the power of this, of thinking a little bit bigger than these one-off interventions. And then finally, I'm going to want to check and see, did my interventions actually have some impact? So here are a couple of cards showing some interventions. So we've got Project Phoenix, leadership, and 2 leadership shakeups, 1 for sales and 1 for marketing. Down here, I've got them kind of what problem we want to solve, increase the retention, and then the different ways or assumptions that we're going to make and when we started and ended them. Using some data flow work, I was able to look at what was the average retention rate beforehand and afterwards and chart that difference. And so we can see for this one, we actually dropped our retention rate or our turnover rate. So it actually got better. This one, it increased, not as good. This one also decreased it. But increasing or decreasing may not mean a lot if there's a lot of variation within the data itself. And so this is why I really like these charts, is because I've got my upper and lower range. What's the normal range that this data bounces around in anyway? And so while I I dropped the value, which was a good thing. It didn't really move outside of the normal range, so it could just be random noise. My personal intervention didn't actually do a whole lot. At least I can't. It's harder to attribute the changes that we made to that change. But again, same thing for this one. Even though it increased, it may just be the random noise because there's a lot of variability in the data. For this one, however, the range is a lot tighter, and my value came outside of the range. So there's a much higher likelihood that this project did have an impact. And of course, there's more statistical analysis and tests that are far more rigorous that we can do, but this would allow us at a baseline to think, okay, something is different because we're now outside of our normal range, and that's really helpful. And so from our really long-term to our medium-term to our short-term interventions, this dashboard allows us to communicate to the end user the value of the model and what it can do for us. And so that's great for the end user, but I'm not always the end user. I'm pretty geeky and I'm all about the model. And for me, I want to scale myself so that I can set the model, forget it, until I actually need to come back to it again. And so this model data validation page goes to those other steps of the model, of looking at the model performance over time, making sure that the data is all good and clean coming in. It also allows me to document a lot of my process so that I'm able to pass it off to somebody else if I need to, or remember what was going on as I come back to make the model a bit better. So I've got my use case, predict whether a full-time model will quit or term in the next 12 months. And here's my model accuracy, a number of ways to measure accuracy. I think this one's using an R-squared value. And so it's about a 73%. And usually if you're doing a static model, that's kind of where you end of, you know what, I've got my accuracy, I can test it with my training sample, I can test it with a tested sample, my out-of-bag sample, and kind of see where all those things go. And that's my accuracy. But in the real world, things are a little bit different. And so this is one of the greatest things about Domo, is this next card actually pulls in the data of as things are happening and compares what's actually happening with the scores that we gave them. So here's all the terms that actually have, all the people who have actually quit since we've rolled this out. So we have their employee ID and their actual term date and then their tenure. And we're able to predict that. We have their predicted tenure as well with their confidence interval, upper and lower bound. With this one, we overestimated. We thought that they were staying 42 months, they only stayed at 36. In this case, we thought 48, it was only 36. This other one we underestimated, and then in this one we kind of got right around the right area. So we said 30, it was 31 within our standard errors. It's fantastic, it's good. By looking at all of these in my summary number, I can actually say in real time, how well is this model performing? And it's at a 67%, not far off from the 73, a little bit lower, which is to be expected since this is new data the model wasn't trained on. But I can see, here's 67%, about 17% are overestimated, 14% are underestimated, but 67% are within that range. And so this gives me a lot of insight as to when I need to come back to change this. And if I needed to, I could set alerts on this to say if my predictions on real value drop below a certain level, and I feel like that level is not right enough. And there's a lot of ways you could do that, or to try and figure that out. I haven't heard of a really compelling one other than just the domain knowledge of we think we can get to this level of accuracy, and if it falls below that, then change it. So I could say, if our correct predictions falls below 65%, then I want to retrain. And then I can try and find more variables or different types of data, different transformations, maybe different model type to try and get that prediction level up again. But I'm pretty happy with the way it is right now, but I can do that all in real time, which is a pretty difficult thing to do with model production. I can look at all the different times that I have retrained the model. And so here in this data set, these two are actually the same. So this is a trended line showing my R-squared valued over time. Here's my training data set. So the number of records that I use continues to increase, which it should, since I'm constantly getting new data. And then I can look at the split, the R-squared, MAE, RMSE. Any of the fit statistics can come in here, and I can check and see how those are all changing over time. I've got my model summary and insights, where I've got my coefficient values. Again, this card looks familiar. It's just the same one that's on the other page. but just here for reference. So I've got a chart type, and a table to view those coefficients. And I can also then put a lot of documentation here about what's going on, why it's happening. So maybe my manager is wants to get a little bit more into the details, but doesn't quite understand. I can use my text cards to add a lot of that information to allow them to understand what's going on and really drive the value, hopefully, to my managers and get the recognition that I did something cool, that this model is actually helpful and it's performing fairly well. Here I have some more fit statistics and a confusion matrix. And then I get down one step below. So that's all the model stuff. Now we need to get into data because we want to make sure that our data is right. And so using some clever data flows, again, that my brilliant colleague Vishaka built, we actually look and check the data types and ranges for all of the numeric variables and for the strings, for the categories, to make sure that all the categories that we're expecting are correct as well. And if everything is correct within the normal ranges that we can see, then we've got nice, happy smiley faces. If there's not, these cards fill up. And actually, if we scroll down a little bit, in my testing data set, I've got an unhappy face. And it turns out the management succession field is actually broken. And so I did dig into this, and thankfully the testing data is not part of my normal flow. It's just a data set that's kind of set aside so that I can do some testing with it, but it's not valid. That my management succession, as I looked into it, the columns that are in there, the categories that are in the management succession thing, there's something wrong. And in this case, it was someone fat fingered in a space, which is a very, very hard thing to find out. Spaces are notoriously difficult because you can't see them, white space. But this caught it, that it did not match exactly what I was expecting. It throws an error. And now in my feature engineering and my data cleaning step, I can put that in so that I always get rid of all the white space. As soon as I do, and this runs through that part of my model flow, my testing data validated will turn back green. This will go back to 0, and everything will be fine. And I'll know that if that problem ever comes up again, it will automatically be taken care of. Now, if it did come up in my production data set or in my training data set, and this is the part that I think is really clever, the data flow itself would return a output data set for the model of 0 rows, which would then error out all of the subsequent steps. So that end user dashboard wouldn't change. All the data sets would remain constant. Things would continue to work. It wouldn't be updated with new data, but that's good because the new data is wrong. And so I do have alerts set on these so that I know when any column errors out, and that way I can go in and I can fix it well before any of my end users have any problems. And that way I look like a genius, which is something I always like to have happen. Doesn't always happen, but I like to. And so this is one way that I can do that. Now going back a little bit farther, we talked about the data cleaning part of the process and the data engineering. And a lot of that is really just understanding your data. And so I've got my data profile. And in here, I've got a lot of different cards. So I've got my summary statistics. So for every column within a data set, I've got how many there are, depending on what type it is. Are there unique values for strings? What's my min, mean, maxes, standard deviations, the top value, the frequencies of different things. I've got all my summary stats right here, so I can kind of start to understand what's going on in my data set. If I want to look at things in combination, I've got my correlation matrix, where I can see all my correlation values. If you're not familiar with correlations, it's actually taking kind of a scatter plot of two different variables and seeing how closely they move together. So the values in a correlation, these are Pearson correlations, they go in between the range of -1 and +1. So negatives mean it's a negative correlation, so as one variable increases, the other variable decreases. If it's a positive, one variable increases and the other variable increases. And if they increase at the level of 1, then for a 1 unit increase in variable 1, you get a 1 unit increase in variable 2. The ones here we see are where they're the same. So attrition number and attrition number, it's the exact same thing. So of course it has a correlation coefficient of 1. There are some other ones that are highly correlated. So if I look at age, see that job level correlated at 0.5, 0.51, 0.5. These are moderate correlations, 0.6. If there's a specific thing, since this is just a card, I can look and say, I just want to look at age and attrition number. And then I've got a nice, easy view of all of the correlation coefficients. Not a lot's going on in here, but it is something that I can look at and start to figure out how I may need to adjust my model. Do I need to change it? Do I need to compress some data? Do I need to leave some out? All this is very helpful in figuring out what types of models or what sort of data engineering I may need to do in building my models. Of course, then I have other cards. So I've got my age histogram, which shows the distribution of age. It goes a little bit more detail than my normal summary statistics. The other thing is we've put in the summary number a count of the nulls. And so I think I mentioned this before, where when you're doing data science, we shift from just do we have the right columns to are the rows right? And null rows or null values inside of a column or inside of a row cause severe problems. And so if there's nulls, and it's an important variable, we may have to throw out that entire row and all of the data with it, which we don't really want to do. Sometimes that's the best idea, sometimes it's not. But we need to investigate to figure out what's going on. So figuring out how many nulls there are and what percentage of that is there that is null helps us figure out what we need to do with those values. Skipping over here, then I've got some bar charts, just looking at my categories, again, my nulls, but this lets me see the distribution of my categorical variables. Again, it's Domo. I can click on any of these, and filter down. Didn't turn on my interaction filters, let me turn that on. Interaction filters, and I can see my age distribution. If I click single, it'll filter down. So the age distribution for the single people is a little bit different than the entire population. It's a little interesting. So there's something going on where age and marital status should be a little bit correlated. Speaking of correlations, I've got my scatter plot matrices here, or my scatter plots. Not a matrix anymore, but just an individual scatter plot where I can look at two different variables. And I've got a line in here showing kind of the slope. It's about 7.6, so we've got our correlation coefficient. And again, these will change based on our interaction filters. So this scatter plot also changes. The correlation is a little bit different for our single population. What this indicates to me is that marital status is actually something that's interacting with a lot of other variables. It's probably interacting with our dependent variable that we want to predict. So this is probably going to be something that I want to keep inside of my model. I've got a couple of other cards here. So you'll notice I've got some box plots. Look at this one, monthly income. So my dependent variable is attrition, and it's categorized as a yes or no. So no, they haven't quit, yes, they have. And for categorical variables, a lot of times, for numeric variables, when we want to compare against a category, we can't use a scatter plot anymore. And so one thing we use is a box plot. And what we can do is say, what's kind of the range, the interquartile range, which is the box. What are the outliers, which is the whiskers. These are also sometimes called box and whisker plots. And then this line in the middle is our median. And so are they the different? And in this case, they are. But the monthly income for people who have quit is lower. The overall range is lower. It's shifted down compared to those who stick around. And so the people who are sticking around, it looks like, are paid a little bit more. So again, this is probably going to be an important variable in my data set and in my model that I want to pay attention to, because it looks like there's a difference. So all of this generates the data profile. And these are just a handful of examples. There's a lot more we can do with this. One last thing I'll say is, I'm going to look at this age histogram chart, is I want to check the distribution of my test and train data set. So as I said before, we break apart test and train so that we can make sure that we've got a good sample of our data to build a model on and then see how it responds to new data that it hasn't seen before. But we want those to be representative of the data as a whole. And so with this chart type, this gray bar indicates kind of the group. How many people are there in each one of these age categories, age years? And then by looking at my test or my train, I can say, do these fit that same general pattern? And the answer, I feel, is pretty much yes. The testing data set is a lot smaller than the training data set, but this looks about right. They seem to have roughly the same distribution. And so I'm fairly confident that my test train split not only are good for each other, so I should get a fairly good accuracy there, but they also represent the overall data very well. And all of this is enabled by having everything in Domo and being able to manipulate the data structures in unique ways. So if I go in and start to look at the data itself, just going back farther and farther and farther, I've actually made tags to look at, here's my model data sets. So I can see how many cards have been built off of them and how many rows each of them have. I can look at my validation data sets, which power those cards that alert me if anything's wrong. I can look at my feature engineering data sets to see, what's going on there, all the way back to my initial model input. And this is the data import or the acquisition piece in the process. Where did our original data set come in? This data set actually comes in from a file upload. Ideally, it would be something from our connectors where it's automatically being pulled in on a regular basis. We have 644 of them that we can just suck in at any time and then start to manipulate and change, going through those processes of cleaning and feature engineering. But having them organized like this, I can quickly go through and see what's going on. So I can look at my feature engineering data set, come over here, and dive right into the actual code that I'm using to generate this. In this case, I'm inputting, this is my feature engineering or my cleaning data flow. So I've got my input, I'm writing SQL code to actually generate some, to do some transformations. And then I have got my output data set. And that's what I was just looking at. If I come here, I can see, diving into the data a little bit more, I can look and see how many people have access, how many data flows have been created off that, the lineage, where it comes from. I can set PDP permissions or even alerts. This is my feature engineering. I don't actually have any alerts because it doesn't really matter. All my alerts come off the validation. But I can look at my model data set as well. And I want to say that this data set, coming in here, looking at the data flow, I can see every time that it was successful, every time that it failed, what version I'm on, and I can actually go back and look at all these different versions. When I build data flows, I don't know about everybody else, but it usually takes me a couple tries before I've worked out the bugs and kinks. I'm usually up to a version 4 to 6, and I've got some data flows where I'm on version about 300. But coming in here, we can actually look at the code and how Domo is orchestrating all of this. So with my data set that's coming in, I'm doing a whole bunch of things. I'm selecting columns. Down here, I've got a rank and window function to do my test train split. I've got my summary statistics. So this is some Python code where first I'm just using this library to import the data into this specific tile. This is unique to Domo. I'm using the pandas library, reading the data set and describing it, and then doing some data manipulation to get the output in a nice format. Here's the code for my correlation matrix that we walked through. In Python, it's really easy. It's this one line of code. That generates the correlation matrix. Everything else around here are little debugging statements, or we've got this bit of code that actually changes the data structure to make it easier to work with the visualizations that we have inside of Domo. Very simple stuff. The model itself is actually right here. So this is an R script. So I can easily interchange between R and Python. And I'm loading in the data. I'm using a library for data manipulation, reading in the data, and then this is what a model looks like. So this is a logistic model, a couple of factors in it, and then I'm creating, in this specific data flow, I want an output that gives me my data set coefficients. So my variable names, my estimates, and my standard errors. And so I'm popping that out. I've got other ones where I generate my confusion matrix or my confidence intervals around my other model fit statistics. And then here's where I generate a new column with the data using the predict value. So the code, if you've seen R or Python code and familiar at all, this should actually look pretty clear to you. If you haven't, it might look a little bit scary. It's really not that bad. But what it shows is that Domo can take the code that you've already written and pretty easily put it into production. The main constraint that we have is that the output has to be a data set, has to be a data frame. And we can only have one data frame per tile. And so that requires us to be a little bit creative, but we can run all of these things in parallel. They're all running off the same data set. And so they're running in parallel, they are doing their job, they're outputting their data sets. And what's best is, again, putting data sets in production is the settings. This will update every time my input data set updates. I don't have to worry about it. The data set updates and it runs. If I don't want it to update when the data set updates, I can uncheck this box and it won't run until I tell it to. If I wanted to, I could run it on a schedule, so it would just run every day. There's really all sorts of configuration things here to make sure that the model gets built the way you want, and it gets run on the data that you want and on the schedule that you want. And that's the essence of productionizing data science. So I know this went a little bit into the weeds, into the deep guts of it, but there's so much value here in having something, an entire system where you have complete control over your inputs, your outputs, and every step in the middle, so that you have the insight into what's going on and then can communicate that insight to the people who really need to make decisions. And it's far better than those static reports that often, hopefully they get used, and a lot of times they don't. And I've seen wonderful, brilliant people who don't get the credit that they deserve for their great models, and their models don't get implemented because it's very hard to communicate the value. But this, using it in Domo and with the dashboards that we've created, it makes it very, very easy so that people are able to consume that information, consume it well, and start to act on it. And everyone gets the props that they deserve. So I'll stop the demo.
All right, so that concludes the live presentation portion of the webinar. We're going to jump into the Q&A. We have quite a few questions that have come in, and I'm going to keep taking them as you send them over, and we'll keep answering them. So the question that seemed to get asked a fair amount is, how long does this take? And what can I expect as far as, if I'm doing this project on my own or if you're helping? Doc, do you want to take that?
Yeah, so it really depends on how good your data is. So for our data consulting engagements, we say that we expect to have it all wrapped up and done in 12 weeks after you've gotten your data prepped. So if you can provide us a single data set with all of the fields that you actually need at the right unit of analysis, then it takes about 12 weeks for us to go through this entire process of evaluating it, doing any feature engineering, doing cleaning, putting the model into production, and building out all of those different parts of the data flow and then the end dashboard. So 12 weeks is what we say, but a lot of it, oftentimes those run a lot longer because the data isn't ready, or it isn't in anywhere near clean enough a state. So that's usually the part that takes the longest. And it's really interesting to work with our customers through that, because in the process of looking at their data, most of the people that we talk to say, oh, I've got clean data. And when we really dig into it and look at it almost at a row-by-row level, we find that it's nowhere near as complete as anyone thought, which then sparks a whole lot of conversations. I was actually on a call with someone just the other day, and they were talking about how going through the engagement and going through their data at such a deep level, they were able to answer questions off the top of their hat because they've gotten so deep, they understand exactly how their data is representing reality and all of the strengths and negatives that go along with that.
Awesome. I had a lot of questions about turning the functionality on in your instance. How do I get the scripting tiles in my Magic ETL? How do I get access to Jupyter Notebooks? Is SageMaker integration going to be included? How much does this cost? Going to lump all those questions into one gigantic question. So Domo is, as a product, we're bundling all of those features together, like the scripting tiles, the Jupyter Notebook, the SageMaker integration, which will be coming out later in the next few months. we're bundling all of that together into a single package that we're calling the Data Science Suite. And so the current features, if you'd like them turned on, you'll have to engage with us, like reach out to me. I think aren't we putting my email out on the, yeah. So my email's on the screen right now, or you can reach out to your account rep and we can look at getting those turned on for you, or look at, pricing for you specifically. But yeah, we want to bundle all that together. We don't want to nickel and dime you, and it's the same type of Domo approach where it's just part of a platform cost. And if you'd like some consulting help with Doc or others on our team to help you execute on your first couple of use cases, we recommend that. Of course, you don't necessarily have to have it. We just find it to be really useful. Is there anything you'd add, Doc?
No, other than just you keep calling me Doc.
Oh yeah, sorry, John Stevens.
So yeah, within Domo, about half the team calls me Doc. I do have a PhD. It's a piece of paper. Next question.
Next question. So hopefully that answers that question. If there's more questions around that idea, let us know. But again, reach out to me, reach out to your account rep to get those turned on and to get specific pricing. The next question I had lots of questions that seem to be wrapped around this idea of, hey, if I'm kind of new to data science, if I'm an analyst today and I want to get into data science, I'm not that great of a coder, how intimidated should I be? And if I want to get into this space, where should I start my learning? I want to give my own perspective on this, and then I'd love for John to jump in. I've spent 7 years at Domo, almost all of those as a sales engineer on the technical side and interested in data science. And I've gone through a lot of MOOCs, a lot of online learning tools. I've read a lot of books, and I've done a lot of coding exercises. And I felt like during that process, I learned a lot about the models themselves and how to fit models and how to do some of that work. But it really wasn't until I worked closely with our data science consulting team that I realized really what a clean and tidy data set meant. And it wasn't until I started working with them that I really understood what putting a model into production and correctly monitoring it and making it actionable, what that meant. And so I know that I'm pitching Domo here, if you will, but really, truly, I had spent years of my time studying this on the side quite thoroughly, and I felt like I learned more in my interaction with our own consulting team on those really important aspects of data science than I did in all that other learning. So if you're trying to get in the space, you're trying to learn, I think this is a really smart starting point because it starts right from the get-go with value and starts right from the get-go with putting things into production, which means a clean and tidy data set, which means monitoring all of it. And then, of course, learning about the models and about how to fit them, that's a core component, but it's certainly not all of what data science is. John, what would you add?
Yeah, so one of the things about our team is that almost all of us come from an education background. We've all taught, and that's a really important part for us to convey. We don't want to be able to just come in, lay something down, and be done. We want you to understand everything that's going on so that if you want to, you can replicate it. Hopefully you have a really good experience and come back. But if not, we want you to be able to build, maintain everything that is built, and then hopefully go off and be able to do your own projects and have that knowledge. So we provide extensive training at whatever level you want, however deep you want to go, through PowerPoints, through our meetings as we talk through the project, to make sure that you feel comfortable and can explain every single thing. And the documentation that we do is incredibly robust. One of the things that I didn't really talk about, but maybe I should have, is I really like a feature in R called R Markdown because I'm able to intersperse text with code, and then all of that can be compiled into an HTML file, which can be accepted by Domo as a custom app. And so all of our documentation is custom apps that have all of the a discussion about the modeling, a discussion about the data cleaning, and every single step along the way with links out into your Domo instance and all of the code that is run that you can then take and start experimenting with. And depending on if you ask for it or not, we're more than happy to show all of our failures as well as all of our successes. Because in building a model, it varies a lot of experimentation. That's why it's called science. We experiment a ton, and sometimes we can learn a lot more from those failures than we can from our successes. And so we can put all of those in as well, so you can see kind of why we tried things and how it worked. But from a consulting side, we definitely want you to walk away with almost a master's level understanding of your data and the models that are being used to power your dashboards.
Great. The next question that we seem to get a fair amount of is, how do I identify a good use case? If we want to get into this space, if we want to start working on building our first models and proving it out to our organization, how do I identify a good use case to get started? John, do you want to take that one on first, or do you want me to do that?
Yeah, you go first.
Yeah, so if you're already a Domo customer, or if you've just been working in analytics for a while, what I'd highly recommend is go and look at the metrics that are driving the organization today. What are the, if you've got Domo, what are the cards that everyone's looking at all the time? Or what are the key metrics the organization has identified as being like the key ones? Meaning, we've got these cultural changes that we know are super important to our, our business, or we want to focus on this specific key metric. Once you've identified that, then the next natural step is, have we really operationally defined it? Are we measuring it the right way? And is it a reliable measure that we have? If the answer to all those, if you've got the answers to those questions, the next natural step in your analytics lifecycle is to model that, right? Let's build a model and let's start doing predictive analytics around it and looking at the feature importance and looking at what influences this particular metric.
Yeah, and so while I didn't get into that much in this webinar, we did have a previous webinar with my colleague Tony who did go over this exact thing and finding the use cases and the process that we go through to help with that. If you are not sure that you are ready for data science because you don't necessarily have a use case but you want to get involved, consulting also offers a service where we walk you through that process. And one of my favorite tools to use is called a conceptual model, where you think about all the different things that you would love to predict, and you start thinking about what sort of actions you could take if you could know the future on any one of those things. So we were working with a customer, and they started throwing out, I think they had 15 different things, ideas that they had on where they wanted to use data science and different use cases. And as we started asking them pretty basic questions of, well, what would you do if you could know what was going to happen about this metric or this metric, it became clear within minutes that there was one thing that mattered more than anything else. And the next part of that was then we started talking about, well, what is the monetary gain? When you guys are a business, what is it that this would impact in terms of the bottom line if you could know the future and stage an intervention? And that made it all crystal clear for them, that they could save millions of dollars if they could figure out this one thing. And that was then the start for us figuring out, well, what are the factors that influence that? What are the independent variables? How do we find them? Do you have that data? And it set the groundwork not just for an amazing data science engagement, but an incredible Domo experience in general. So in this process, they have developed a data set that gives them insights and answers to questions before we even get to the modeling piece that they have never had before, because they were finally able to start talking about the right sort of questions. And so that's another thing that we really want to help people figure out, and are more than happy to do that.
So thanks, John. The next question that we are getting in a lot of various forms is basically what sort of models can I use? Today it looks like we covered multivariate linear regression, but are these features helpful for nonlinear types of models? Do you support visualization interaction with like clustering models or decision trees and so on? So that's kind of a lot of questions bundled into one, and I'll let John take that while I get through the rest of these questions here.
So as I showed in the Magic ETL, right now we support Python and R, and you can pretty much write whatever you want in there, and the output has to be a data set. So if you want to write a random forest model, if you want to write a deep neural network using Keras or TensorFlow, all of that can be done, but the output has to be a data set. And these are run in batch, so it has to be a data set that is going to persist over time. And it will update on whatever schedule you set for that, but it has to be, anyway, so it has to be an output data set. Once you have a data set, then you have Domo's full range of tools for the visualization aspect of it. And that includes all the chart types that exist and as well as custom apps. So the what-if analysis that I showed off is a custom app where one of our team members has a lot of experience writing JavaScript, and so she wrote that app. JavaScript has incredible libraries for interactive data visualizations, and so we can use those for other sorts of modeling visualizations if the normal chart types do not work. So in terms of models, literally anything you can code in R and Python. If we don't have a package natively, it's very simple to then talk to our support teams and get those packages added so that you can have those custom functions that you need to run whatever model you need. So tree-based models, neural nets, SVMs, XGBoost, or any sort of gradient boosted machine, as well as logistic and linear regressions. And then the visualization, it's really a matter of how can you structure your data. Do you just need to output the coefficients? Do they need to be in a specific format? And that's one of the things with the correlation matrix that I showed off. Right, the code to generate the correlation matrix in Python, simple one-liner, very easy. And I found that as I was trying to visualize that, the data structure that came out wasn't quite right. So I just modified the data structure. I normalized it so that I have one row for variable one column for variable one column for variable two, and then one column for the correlation coefficient between those. And by changing the data structure, I was then able to utilize the chart types in different ways. So it's really up to your imagination. I've created all sorts of weird visualizations just by thinking about the charts themselves. One thing that may help, it may not, but it may help, it helps me, is understanding that all of our data visualizations, all of our charts that we use, if you go into the analyzer to start building one, it's essentially a SQL generator. Everything that you're dragging and dropping in the filters and everything else, it's just generating a bit of SQL code that's then being run against our data warehouse and then pulling the data back with that data set that SQL has generated and having a specific way to visualize it. So if you can think through how could I write the SQL to get the data set in the way that I wanted, how can I do things with the chart, you can do a lot with those charts. Not everything, unfortunately, but you can do a lot with them. And so thinking about like making an interval plot, you just need the max and mins and the means, and then you use a box plot. And so just get the right data in the right way, and you can pop it out. I was playing the other day with a classification model, and I ran a handful of them. I ran a logistic model, I ran a random forest model, and I ran I used XGBoost algorithm. I generated then new columns of data for my predicted categories, and then just within beast modes inside of a chart, I started creating all of my fit statistics. So my classification accuracy, my sensitivity and recall, my precision, and even my F1 score, because there's simple calculations that can be done in a beast mode. And the nice thing about having those in a beast mode is then I can use the filtering mechanism still within Domo to do whatever. So I hope that answers the question. Kind of a longish answer.
Great. Let's see. I've been trying to answer questions just through the chat while John's talking.
It looks like we only have a minute or two left.
Yeah, only just a minute or two left. Most of the other questions, well, I'll keep answering them even after we let everybody else jump off. But a lot of questions about how can I get the recording from today's webinar. It's going to be auto sent out to you through On24, which is the platform that we're doing this webinar on. I can go ahead and get the registration list and email that to you myself, and so you have my contact information. You might already have it, but we'll make sure that you get that. And then if you'd like to see previous webinars or anything, we haven't put those up on our website yet, or trying to get that up, but if you'd like those links to previous month's webinars, just shoot me an email. My email's on the screen. I'll get those over to you. So we're going to go ahead and end the actual audio portion of the call since it's the end of the hour. If you've sent me a question through the Q&A, I'll go ahead and continue to answer those for the next few minutes, but we want to be sensitive to everyone else's time. So thank you for joining today. My email's on the screen if you have further questions or I don't answer if we didn't cover it. I'll continue to answer the rest of the questions through Q&A. And have a great day. Merry Christmas. Happy New Year. And look forward to hearing from you if you have questions or interest. Yep. Thank you. Bye.